Hi, welcome to Nomis Academy. In this video, we are going to be looking at cycle theorems, and we are going to consider Theorem 6. We are going to state the theorem and as well prove the theorem. So let's state the theorem. It says that if one side of a cyclic quadrilateral is produced, the angle so formed is equal to the opposite interior angle. Okay, so it says that if one side of a cyclic quadrilateral is produced, the angle so formed, or the exterior angle so formed, is equal to the opposite interior angle. So let's take the diagram. We have a cyclic quad. Here is the center of the cycle. We have this. Okay, and let's call this A, B, C, and D. Okay, according to the theorem, we say if one side of a cyclic quadrilateral is produced, okay, let's take the side to be BC, is produced to T. Okay, to T. Now we said that the angle so formed, the exterior angle from here, which is formed, is equal to the opposite interior angle. So this angle is equal to the opposite interior angle. So we can say that angle at A is equal to angle at C. Okay, according to the theorem. So now let's prove this theory. Proof. Given a cyclic quad, we use the short form of quadrilateral ABCD and comma BC is produced to T. Okay, we are to prove that angle BAD is equal to angle DCT. Okay, according to the statement in the theorem. Okay, so construction. Do we have any construction? As you can see, none. We just put none. We have no constructions to make. All right, so let's now go ahead with the proof. Okay, let's clean the other side of the board. All right, to prove. Now, we agree that angle BAD plus angle BCD sum up to 180 degrees, and the idea behind this is opposite angles in a cyclic quad. Okay, so we agree with this. Now the next thing, we also know that BCD plus DCT is equal to 180 degrees. And the idea behind this is angles or sum of angles in a straight line. Okay, sum of angles in a straight line. So let's call this equation 1, the first equation 1, and the second equation 2. So you can see if angle at A plus angle at B sum up to 180, and then angle at C and also this particular angle sum up to 180 degrees, then we can say that the left hand side here is also equal to the left hand side of the other equation. So we can say by comparing the two, or equate equation 1 and 2, equation 1 and 2. So let's equate the two together. So let's clean this side of the board. So we agree that BAD plus BCD is equal to BCD plus DCT. Okay, so we agree that these two sides, the left hand side of this equation is also equal to the left hand side of this equation, since the right hand side are equal. So we have this. Now we can take this to the other side. BAD is equal to BCD minus BCD plus DCT. Okay, so we have that. Now you can see, since this 2 is negative, so this is subtracting from itself, so that is 0. We have BAD is equal to DCT. Okay, hence proved. So this is what we are asked to prove. Okay, we are to prove that BAD is equal to DCT, and that's what we have here. So this is the proof that the exterior angle formed when one side of a cyclic quadrilateral is produced is equal to the opposite interior angles. Thank you for listening. See you next time. Bye.